Hey guys, I'm going to help you set up the graph for the magnetic field graph assignment. So we have some data right here, and number 1 says to create a line graph and include axis labels, a title, and an evenly spaced scale. So I'm going to start with the title. So this blank white field over on the left, we are going to say that this is my science notebook, and I'm going to title it Magnetic Field Graph. It is hard to write on my computer screen, so sorry for my messy handwriting. Magnetic field, oops. Magnetic field graph, because that's what the assignment's called, so that's why I'm titling it that. And I'm going to underline it, and I would update that in my table of contents too. Now, I'm going to make a nice big graph. Hopefully I have room for it on my screen here. And the thing that goes on the x-axis is the thing that we change. In this case, we can't change how strong the magnet is, but we can change how far away we are from the magnet. So distance from magnet is going to be my independent variable. And the independent variable always goes on the x. Distance from magnet. I know my handwriting's messy. Sorry about that. Okay, now I'm going to look at my data. The smallest number on my x data is 1.5, and the biggest number is 5. So a good scale that I can think of is to go by 0.5s. I think that'll be a good way to do it. So I'm starting with 0 in the corner, 0.5, 1, 1.5, and so on. The highest I need to go is 5 because that's the biggest. That's the highest my data goes. Now mine is a little squished because I didn't have room below this without scrolling down. I didn't have room to put the title down there. So yours should hopefully be less squished than mine because I just have a small screen. Anyways, the thing that we measure goes on the y-axis. In this case, we're measuring the magnetic force in Teslas. So I'm going to put magnetic force over here on this side. Oops. Magnetic force. I'm having technology issues. Okay, so magnetic force goes on the y-axis. Now look at this data. The y-axis data is a little bit trickier. Our smallest number is 7.58, and our biggest number is 136.28. Wow, that's a big range. So the easiest way to fit all that in, I'm thinking, is to go by 10s or 20s. For you, I would recommend to go by 10s. My screen, I don't have room to go by 10s on this small screen, so I'm going to have to go by 20s. And even then, I don't think I'm going to fit all these numbers in here. But in your graph, it would look much better, I think, if you went by 10s. Also, I think since you have more space on your science notebook, I think you can make yours look a lot better than mine, because I'm having issues with the little screen. Okay, I had room to go by 20s. Whoops. It just looks a little squished. Oh well. Again, on your notebook, you have more space, so it should look better for you. Anyways, so now I'm going to start graphing my data points. So my first data point is 1.5. 136.28. So I'm going to find 1.5 on the x-axis, and then I'm going to trace it up to 136.28, which I just have to guesstimate because I don't have it exact. That's why I told you should go by 10s. And if I had room, I would have gone by 10s, but I know I would have run out of room, I'm pretty sure. Maybe I would have fit it. Anyways, so that's our first point. Then we have 2, 74.26. So we find 2 on the x-axis, trace it up to 74.26, which again, we're just going to have to guesstimate. Next point, 2.5 and 46.06. So we find 2.5 on the x, trace it up to 46.06. Again, we just have to guess where that is and kind of approximate it, okay? Next point is 3 and 23.02. So we find 3 on the x, 23.02 on the y, make a dot. Next we have 3.5, 16.3. So we find 3.5, trace it up to 16.3. Next we have 4, 11.5. And again, I'm just guesstimating, and yours, if you went by tens, it'll look better and there will be less guesstimating. But I don't have a ton of space here. So next we have 4.5 and 8.62. That's getting pretty close to the x-axis. Next we have 5 and 7.58. That one's even closer to the x-axis. So now we have to connect these dots with lines. Okay, that's not perfect, but oh well, it gives us the idea. And we also need a title. So for our title, we take the x and the y-axis titles and smash them together. So we're going to say distance from magnet versus force. Again, I'm sorry for my messy handwriting. It's hard to write on this screen. Distance from magnet versus magnetic force. And I always underline my graph titles so we can tell it's a title. Okay, so that's number 1. We got that one. Next, let's see what it says. Number 2, as objects move closer to a magnet, what happens to the force? Well, closer to the magnet is over here. So if it's closer to the magnetic force is pretty strong. If it's far away from a magnet, the magnetic force is much less, right? So for number 2, I would say as objects get closer to the magnet, the force is stronger. For number 3, I would say as objects get farther from a magnet, the force is weaker. And then for number 4, the graphical model is this graph that we just made on the left. The illustrated model is this drawing here on the right. So you need to say some pros and cons of each one. For example, a pro of the graph would be that it is more precise. It has exact data and exact numbers. But a con of the graph might be it's hard to understand. A pro of the illustrated model might be it's easy to understand and it shows the lines of force. A con of the illustrated model is it's not as precise as the graph is. Okay, so hopefully that was helpful and good luck on the assignment.